Did you know that geologists might be able to tell where you went on vacation just by analysing the sand stuck in your backpack? And without ever actually seeing that sand.
What are you going to do that based on?
X-ray diffraction.
A method that uses a so-called XRD scanner. You put in finely ground soil and sand samples, and it returns a graph like this. These diffractograms tell us exactly what minerals are hiding inside the sample. Normally, you'd turn to trusty online mineral libraries to figure it all out, but not this time. For this series, we threw the challenge to Earth materials specialist Arjan Dijkstra and told him to go full Sherlock, no database allowed.
This one's easy, I think.
In episode 1, Arjan explained how the XRD scanner works, and we learned it's not as simple as just dropping in raw sand.
Welcome to the Geoscience Lab.
So today, we're joining Katrin in the world of sample preparation. We've been told it involves a wild machine that spins 40 times faster than my favourite ride at the fun fair. So naturally, I had just one question. Where's this awesome machine?
This is our PM200, our planetary ball mill. We always use this one to mill rocks or sand. This can even in 10 minutes crush granite, and that is the hardest rock we have.
I immediately wanted to toss in the sand to see what would happen. But I had to be patient. First, we had a few other stops.
The journey always starts with the ovens, drying the samples, get rid of all the water.
Otherwise, it would turn into mud during milling, making it useless for XRD. So how long does the sand need to be in the oven?
And normally we dry them 24 hours. And then we have a closer look at the samples, and when we see that they're still wetty or stickery, then we leave them for another 24 hours in the oven. Because every sample is a different one, and you never have a standard procedure. Always looking at your samples.
24 hours? Luckily, Katrin had already taken care of that part, so we could move on to the next step, administration. When working with multiple samples, good labeling is everything.
And we have the green sand.
Look at that, our perfectly dried sand. Almost ready for a ride in the PM200.
Working with a ball mill, then you always talk about balance. We have 2 jars inside the ball mill, and they need to be balanced. When one jar with a sample is really heavy than the other one, the machine will break down. So balance, it's all about balance. Students ask me, how much sample do I have to add to my grinding jar? I can say, I don't know, because every sample has a different weight. But it can be also having a different volume. For example, 1 gram of gold is very small. But when 1 gram of feather is even 1 gram, but has a really much bigger volume. So I never can tell because it depends on the sample.
Here, Katrin uses exactly 1 gram of sand per side, and then she added these balls.
7 of them.
What exactly are those, Katrin?
During that grinding process, when we have placed the grinding jars in the machine will turn around itself, and also the jars will turn around on their own axis. So during that process, the balls will also turn on a high speed inside these jars.
At such high speeds, these balls go full demolition mode, putting even the grinding jars at risk of wearing themselves down from the inside out.
These are made of zirconium oxide. This is a really, really hard material, so that you not get a mix of the jar and your sample. We will close the systems, and then I will place the grinding jar in the machine. This is the sound of I'm fastened. Checking. This is green. This is green. We have very soft sand, so I'm thinking about 5 minutes at 200 RPM.
It may be hard to believe, but this game is not about brute force, It's about finesse. Cranking up the RPM too high risks crushing the minerals beyond recognition for the XRD.
Okay, and the machine will start.
We listened to this sound for a while, and I thought the magic was already happening. But Catherine's trained ears heard differently.
At the moment the ball mill is spinning at 200 RPM. I'm hearing no sound, just a flat sound, so the balls are not moving, so there will be no grinding process. So I will stop this measurement and I will go up to 300 RPM. Start the milling process. This is the sound of turning balls.
After 5 minutes, Catherine releases the jars from their thrill ride.
I'm using a little bit material from the grinded sand against the wall. And there I feel if it's powder or still some bigger pieces that needs to be longer. But this is fine powder, so we are done.
And the sand literally looked a little shaken. White-knuckled sand? Is that a thing?
These small particles compared with the original bigger particles having a bigger surface. And this reflects more light than the smaller one. This is why it turned out whiter.
I thought it might have been motion sickness, but the real explanation was, of course, in physics. Now, the last thing that remains is for Catherine to prepare the sample holders that go into the XRD scanner. She carefully fills the sample holders that'll go into the XRD scanner. Just a tiny scoop of powder, but one that hopefully holds a beautiful, even mix of all the minerals that were in the original sample. Now it's ready for the XRD scanner. If you want to learn about the magic that happens in this machine, or to see if Arjan can guess where the sand came from, make sure to check out the other episodes in this series.